response video to Hythloday. He's raised some issues. Brought up the word Lesage, which I really hate because I wasn't inspired by Lesage gravity. Yes, it's a similar theory of gravity, but it's not my obligation to defend Lesage gravity. But anyway, in a broad sense, because it's not the same kind of mechanism. So I guess that's one of the fundamental things that has to be conceded in this argument. I'm saying matter is made out of energy, energy still in motion, and that when you acquire a velocity, any velocity, your matter changes, meaning you acquire energy moving in that direction of your velocity. You have an imbalance now. You have extra energy moving in the direction of your velocity. You possess it. You possess that directionality as part of yourself, not as part of the environment or anything else. It's part of you. It's part of your identity. Alright, so back to the orbit thing. I'm trying to come up with like the dancing thing for time dilation, which I think was a good analogy, a way of explaining, and I know the fact that I have developed this doing videos means there are videos that say things that I would say aren't true anymore, because I've modified the theory, or advanced it, I would argue. So I can see there's room for confusion. So the point would be is that the Lesage gravity creates this problem, where if something has a velocity, if it's interactive with this ether or this field of force, there's going to be more of interactions ahead of it, and that would somehow create a problem of friction, or degrade its capacity to move through the medium. You can't have it both ways, right? You can't have it have an impact in one circumstance and not have an impact in another circumstance. But in a sense, you can, if you understand what this acquisition thing is doing, and the fact that the fundamental mechanism is made out of the same stuff the field is made out of. It's just that it's doing this orbit thing. It's a pattern, and it's a pattern established by the same mechanical mechanism that's doing the gravity and the magnetism and electricity. Those forces are what's holding the pattern together. So the pattern has an identity, and not a rigidity, but it has this thing called inertia. It doesn't change without forcibly being changed. For my hand to move, every quanta inside my hand, even the bits going this way, have to somehow not do this, and they somehow have to do that. So for some period of time of the existence of this matter, the bits going up and down just can't be doing that as much as they were for me to move my hand. It's the dancing argument. Alright, so I was thinking of an analogy. So think of the matter as a wheel spinning. And when it has velocity, it essentially has more tire. So if it's a tire, it has taken a piece of tire from over here and put it up here. So it has more tire going this way than it has tire going this way, in the simplest terms. When you have velocity, there's an extra bit, okay, inside of you going the direction of your velocity, and there's no bottom to that tire. The wheel's missing the bottom. And essentially when you're moving into the field is giving you more of this coming at you, and you're essentially just riding temporarily on that extra bottom provided by the field. So as you go faster, more stuff comes in, which is very convenient to balancing the wheel. Now the wheel has a bottom. So now you can have a longer top because you have more stuff coming in to make the bottom. So your circles can be completed. So I mean, I've used analogies for like a spinning circle, in a direction. And the idea would be is this component here is not part of the matter. It's being provided by your velocity. Your velocity is creating a circumstance where now this extra coming in just fills in all these bottom loops, so now you can afford to have more going out. So again, we're back to this, like say if I was to try to take an orbit, and like I said, we're just cutting it into its basic essence, which is this, 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 and this. And we're just doing it in 2 dimensions. And for the sake of argument, electrons might just be 2-dimensional, but that might be the nature of polarization. But I don't want to confuse any more than we've already confused. So all you really have are these balance to have an orbit. And I would argue for matter to move the speed of light, you would somehow have to get, like the speed of light in this direction, you'd have to get rid of this and this and this. Those things can't exist, and you still have the speed of light. I'll be back. Back. Alright, so you have to get rid of these extra elements. So if I was trying to draw something, change this into something going very fast, I mean, you could start off by saying, okay, well, make it go a lot more of this, but you still got to do some of this and some of this, and then you'd still have a big pile of this. But so the idea would be is that the environment takes care of this part for you automatically. So in a sense, you can maximize this part of your matter. So this is really what your matter is. It doesn't have that whole bottom part. So in a sense, you are just getting rid of the stuff that's not necessary. And so obviously if I'm moving faster in the environment and I'm getting an equal, for my speed, I'm getting an equal amount of in coming in. So the faster I go, the more ins that come in, then it constantly recreates this balance that I need to maintain this orbit. And to explain, I mean, the same thing is happening on the tangents. But like I said, if you wanted to draw the speed of light, it would be one long line going in one direction, right? So all the little bits would be converted into bits going one direction. And anything slower than the speed of light, would require something to compensate. So you'd need a compensation in terms of once you have a tangential direction, a perpendicular component to this in terms of an orbit. That's when this extra from the field is convenient. And as stated, the pure kinetic reaction, I mean, I've sort of been over the kinetic part, but the pure kinetic reaction is invisible to change. I mean, it's two things go in, 2 things go out exactly as if they never hit each other. So it's not a meaningful event. But the meaningful event is the replacement of this component. So when you acquire velocity, you have to give up something. So what's basically the stuff you give up first, right? Say you're going this way, spinning around. The stuff you give up first is the stuff going this way. That's the most obvious non-player. If you want to go this way, what do you get rid of? Well, I'll get rid of the stuff going the opposite way, but that's really a drag. This stuff isn't doing me much good either. But again, so that's part of what velocity takes care of, in that these tangents have to keep getting replaced. So the perpendicular elements, they have to keep getting moved forward. And so they are flipped out, in the sense they're released, and then a new tangent in a forward position is acquired. So, but for both up and the down direction. So as you gain velocity, you're running into more tangents also, but that's good because you need to keep updating your tangents, because your tangents need to move forward with your velocity. I mean, your perpendicular elements. But I mean, the speed of light argument sort of makes it make sense. If you just try to think of taking something circular that has these elements in different directions, and realize that when you attempt to convert it into one direction, that it's going to have to sacrifice something. And the easiest bit to sacrifice is this opposite direction, which you're getting from the field. But again, you're also getting more of these tangents, and you can just replace those. So I don't want to put more than one subject in this video. And I don't know if there's anything else I need to say. Maybe that's enough of an explanation. But I'll use the analogy of you're basically, when you have velocity, your atoms have to roll through space. They can't just magically move. Something something just sitting here can't just magically move. It has to be moved. And to be moved means stuff that was doing this has to push it along. So the extra velocity, you know, the velocity has to be spread out over all the components. So say if you did have a square and you hit it with one extra arrow going this direction, that extra arrow has to be turned into a little tiny arrows that are basically put on everything to move every bit that's not going the right way. So everything going the wrong way, these bits are all okay, bits are going the right way. But all these little bits here have to be pushed into the new position. And it's the spreading out of that force that ends up being your velocity. So you get hit by a certain number of, you absorb a certain number of extra arrows. But remember, it's absorption of the directional information. You're not absorbing mass, you're just absorbing identity. So you're exchanging the bottom of your tire for more top to your tire. So it's probably a good way to draw it. You're cutting your tire off so you can expand the top part of the tire. And now you're letting the field fill in the bottom part of the tire. Effectively. So now you can afford to go further this way with each rotation. And that's your progress forward. So you're not gaining any mass, but the mass you have is all converting into one direction. And predominantly more of one direction. And you're just using the field to create the illusion of balance. You're rotating, letting the field complete the balance, rotating, letting the field create the balance, rotating, letting the field create the balance. So you're just riding on the field's energy. And that's where you're allowed to have an imbalance that's still balanced. It maintains the integrity of the orbit because it doesn't have to degrade into a bizarre shape. It can still maintain its shape, its proportionality, and yet have the because the stuff you need keeps showing up to replace the stuff you had to get rid of to have the extra velocity. Something like that. But the real thing to understand is that there's the dynamic inside of this thing. These connections between these little bits is all being established by the same kind of field pressure. And so things don't get out of shape easily. That's probably the wrong way to put it. They have a tendency to seek balance. By tendency. I don't know if it's by rule, but it's by tendency. And essentially tendencies become rules, right? Alright, well, it's not, I don't want to drag this out, but the point is all the energy when you gain a velocity, every bit of imbalance you have by gaining the extra arrows in the direction and losing arrows in another direction, right? You've changed the proportion of your arrows. If I have 10 going this way and I only have 5 going this way, well, the point is if I have 10 going this way, I'm going to pick up that extra 5 going this way to create the bottom of the tires, and I'll still be expelling the same amount. I'm not absorbing that energy, I'm just using it temporarily to keep a balance state. So it retains balance by using the extra force you're creating by having velocity as a complement to your velocity. Something like that. Alright, well, that's probably enough, and so we'll label this something relevant to, well, something, I don't know, I'll think about it. I mean, it's a response, so I'll leave it to that for now, and then I'll reference it if I need to. But I just see if this covers, if this explains it, so he understands how there's no friction, that the extra that you're running into, because you're moving into the ether, perfectly complements the imbalance that you've created by moving. Your movement is an imbalance. You're correcting for the imbalance by actually having more of the very thing you had to get rid of to have the velocity. Okay, leave it at that. But yeah, I'll try to keep these subjects separate. He has them combined in the video, and I don't think that's a good idea. So I'll do polarization and magnetism next, presumably.